All right, so we're back here. I had a little bit of an issue with the video, so a lot of the stuff is already typed in, so we'll have to watch it. But let's see here. I changed the symbols a little bit in the Z statistic formula to make it a little bit easier. So I changed it to a lot minus a little so we could keep track of what was going on. And so let's go look at Excel here for a second. What I did was I changed here to the P for a little, which was the less than an hour a day, which is 5 out of 88, and the P for a lot right there. And then we found that P hat before. So what I did was then I took the difference in the two P hats, the P for a lot minus the P for a little, a bit of TV watching. And then I found that giant denominator. It's the square root of B8, which was right here, P hat, times 1 minus P hat. And then over here, 1 over 619 plus 1 over 88. And notice you have to close off this square root and then times it by the next square root. So they're each separate. And that gives you your denominator. And then I just took that numerator, that difference, divided by that denominator, and I've got my Z0, my test statistic, which is 4.0359, which is what's right here, 4.0359, right there. Then I need to find my critical values. Well, let's see. Since it's alpha's 0.05, what you need to do is go to norm dot inverse, or norm inverse actually. Either one will work. So if you have old school Excel, you can just do norm inverse or norm dot inverse, either one, okay? And then you can say, okay, take that alpha and cut it in half, right? Because that's what it says to do in the table anyway. Alpha cut in half because it's a two-tailed test. If it was a one-tailed test, that would be different. You'd just leave it as alpha, or 1 minus alpha, depending on whether you're right-tailed or left-tailed. Then you tell it the mean is 0, the standard deviation is 1, because this is the standard normal curve. Press enter and you've got it, negative 1.960. All right, so then back to my classical method, because it didn't tell us which method to use, so of course we're going to do both, right? All right, so here's my critical values, 1.96, negative 1.96, there they are. And we're going to reject the null hypothesis because our test statistic, which is 4.03, that's 4 standard deviations past the mean, is way rare. And it's definitely in the critical region, and it's definitely past our critical value of 1.96. So we are going to reject. Technically, this is 059. Right. Cool. All right, so now let's do the p-value method. The p-value method is my favorite, of course, as you guys have learned. Let me go make a picture of it so you can see. Hold on. So the thing about the p-value method is that you know these numbers already. They're the number that you found in step 3, namely the test statistic. So those are the numbers you're putting down, not the critical values, which is the classical method. So the p-value method, you put down your test statistics, and then you have to find what your p-value is. What's the probability that you were there or further away? So let's do that. So we need to find the p-value. Oops, it'd help if you spelled p-value correctly. There we go. All right, so it's norm dot dist. It's 4.035. The mean is 0. Standard deviation is 1, and I'm doing this wrong. Hold on. It's going to be true. The problem is that norm dist does left-tailed test, and this is a right-tailed statistic. We're over on the right side, correct? So we can do this 2 ways. You can take the negative of that, right, and then just do times 2. That'll probably work. Let's see. Yep, there we go. So that is the p-value. Now, let me just make sure everybody understands. This is on the right side of the curve, right? Over here. But norm dist wants left tail curves. So I took the negative of it, and that gave me this blue area here with norm dist, and then I multiplied it by 2 to get both the blue areas. Follow? Of course, if this was negative to begin with, if this Z0 was a negative number, then you wouldn't have to worry about it, and you could just use it. Okay? All right, so this is 0.0, think about this, oops, 0.0234, 4 zeros and then a 5, right, because it's scientific notation. So that's my p-value, 0.12345. All right, there we go. We will finish this method up next time, and I will also show you StatCrunch for the same method next time.